next up is David Hoskin, and David is our observing chair, and he does a monthly thing called What's Up in the Night Skies. And so what's up for this month, David?
Okay, let me share. As Paul said, January's not been a great month for clear skies. Hopefully February will be a little bit better, but historically February is not much better than January. So in any case, there are a bunch of interesting things to look for. The title slide, you may recognize this as Kemble's Cascade, which was one of the challenges last month. And I took this picture a few weeks ago during a clear night, and you can see the cascade of multicolored stars ending in the compact open star cluster NGC 1502. So the sun, what's happening with the sun? Well, the days are getting longer, which is always welcome at this time of year. February 1st, sunset was 5:23, and by the end of the month, it'll be 6 p.m. Dawn changes from, gets earlier too. So at the start of the month, the sun rose at 5:53, and by the end of the month, it'll be rising at 5:16. So good for our capacity to make vitamin D. Not so good for deep sky imaging, less dark skies, but on the other hand, the skies haven't been very clear anyway, so it doesn't matter too much. I also note that the altitude of the sun's getting higher, so it increases by a full 10 degrees by the end of the month, which hopefully will bring it above the trees in my backyard so I can do some solar imaging again. Speaking of solar imaging, today's not great, heavy clouds in Halifax, but tomorrow's supposed to be clear. And if you have a scope with a white light filter like Batter Solar Film or Thousand Oaks filter, there's some nice sunspot groups on the sun. This one, AR 2630 or 2936, is just rotating out of view. It was the source of a number of small solar flares over the last few days or so, and there's another group just rotating into view, and there's a couple front and center. These particular ones so far are pretty quiet, so there's not much chance of a big solar flare and a coronal mass ejection. But note, I mean, there's, 5 sunspots currently visible on the sun, and that's holding true for the past little while. Sunspot numbers are now at their highest level in more than 5 years. So it is a good time to get interested in solar observing. There's lots to see on the sun. There is an equatorial hole in the sun's atmosphere, and that's a source of high-speed solar wind, which is causing some auroras, but they're only visible to observers in the Arctic. So hopefully we get some more auroras that we can see in lower latitudes and even in Halifax. This is a hydrogen alpha image of the sun that I copied today from Solar Observatory in Chile. The Daystar site is a good site for daily solar images, just to see what there is, and there's a really nice prominence here, which I'm hoping will still be visible tomorrow when if it's clear and I get my solar scope out. So the moon. So the new moon was February 1. The Mi'kmaq term for this moon is the snow blinding moon. Abu Ganajit. You can click on this link. I'm not going to try because it hasn't worked for me before, but if you go to the package on our site on Astronomy Nova Scotia, you click on that and you can hear the correct pronunciation. February 7th is interesting. It's a good time if we have a clear sky to identify Uranus, which is going to be just 1.2 degrees north of the moon. And so this is what it'll look like around 8 p.m. So you can will easily be able to pick out Uranus from the other stars in the field of view. First quarter moon is February 8th. Full moon is February 16th. And then at the end of the month, there's a nice wide field of view photo op. On February 27th, Venus and Mars will both be close to the moon, and you can see that in this slide. I took this screenshot from Stellarium, and you can see Venus, Mars, and the waning crescent moon line up nicely within a 10-degree arc. So that'll be a really nice photo op, but you'll have to get up at 6 a.m. And hopefully it won't be too cold if you do decide to get up. February and March are good times to see the zodiacal light if you've never seen it. This is a pyramid of light that in the early spring, so February and March, you can see in the western sky just within about a half hour the end of twilight. In the spring, it appears in the eastern sky just before the start of morning twilight. So in the fall, September, October. The reason that these are good months to see the zodiacal light is that it's best seen at mid latitudes when the ecliptic is at a high angle relative to the horizon. But you do need a dark observing site to see this particular astronomical phenomenon. This is what it looks like in Stellarium. So on the 19th of February, if it's clear, around 7 p.m., if you have access to a good dark site, you'll see this glow, this pyramid-shaped, very large pyramid-shaped glow of light after sunset, after twilight. This is a picture I took of zodiacal light last year. I drove out to near 9 Mile River, so the other side of Enfield, and I was able to get a nice shot of on the 13th of March of zodiacal light. You can see the pyramid here, and the Pleiades making an appearance as well. There's a really good article. What's the cause of zodiacal light? It's due to dust reflecting sunlight, and this dust is in the plane of the ecliptic towards the sun. There's a really good article by Roy Bishop in the Observer's Handbook on interplanetary dust, and current thought is that this dust actually comes from Mars. The dust cloud spans the distance from just beyond Mars to the orbit of the Earth. Now, how this dust arises, they're not sure. been suggested that maybe the dust storms that sometimes cloak the entire planet may be responsible for that interplanetary dust, but there's no real mechanism to allow the dust to escape the gravity of Mars, but there may be an unknown mechanism. In any case, the dust has to be renewed. I think the calculated lifespan of an individual dust particle is about 10,000 years. So it is constantly being renewed through some particular mechanism. The moon, lots to see on the moon. The first quarter, as I said, is on February 8th. So the nights of February 7th, 8th, and 9th are good nights to, if you want to have a look at any of these features around the terminator of the moon. You can knock off a lot of the explore the moon and explore the universe checkboxes if you have a look at the moon at first quarter. And of course, as you go past first quarter, some of the other features will start to become visible. So the challenge is to observe 3 of the Mare and 3 craters with binoculars at around the time of first quarter. The planets. Well, it's a pretty good month for planets, with the exception of Saturn, which is not visible. You can see all the other planets at some point in the month. Mercury appears just before sunrise, low in the southeast. Its maximum western elongation is on February 16th, and the magnitude is 0.0, so reasonably bright. Venus, if anyone's got up before dawn, you'll note that Venus is now prominent in the dawn sky, magnitude of minus 4.8, so it's really quite bright. Mars is also present in the dawn sky. It's for all of February, you can find Mars in Sagittarius, magnitude 1.3, so it's easily unaided eye visible. On February 13th, there's a wide conjunction of Mars with Venus. And as I noted earlier, at the end of the month, on February 27th, there's a wide conjunction with the moon. If you're going to see Jupiter, better look soon. It's an early evening object in the sky, but it's very near the horizon in the southwest for the first part of the month. And by the end of the month, it's going to be pretty much, you won't be able to see it. It'll be lost in the light from the sun, setting sun. I don't know if we had it, I don't remember what the sky was on February 2nd, but if you were looking and the sky was clear where you are, you may have seen a Jupiter 4 degrees north of the thin crescent of the new moon. Uranus is in Aries all year, magnitude 5.8, so it's under dark skies. It'll be a unaided eye object. As I said, it passes close to the waxing crescent moon on February 7th. So that's a good opportunity to check off observing Uranus in your observing book. The challenge for the planets this month is to look for or photograph the largest moons of Uranus. They're pretty faint, so they're definitely telescope objects, magnitude 14 to 15. This is a shot from Stellarium showing the location of the major moons, Oberon, Ariel, Umbriel, and Titania. You may recognize those names from Shakespearean plays. but you see how they're going to be oriented around the planet, around the ice giant. And finally, Neptune is still visible. It's low in the west-southwest at magnitude 8, so it's a telescope object. You won't see it with the unaided eye. But until mid-February, it will be visible after sunset, just after sunset. And a couple days ago, there was a conjunction between Neptune and the waxing crescent moon. Winter constellations, these are the same ones that I talked about last month. Auriga, Gemini, Taurus, Orion, Canis Major, and Canis Minor. So nicely lined up, easy to find these constellations. They're quite prominent. Winter stars, again, these are all objects in the Explore the Universe listing. Sirius is very prominent now in the southeast. #1 brightest star. A lot of other bright stars there. It's really worth learning the name of these stars if you have a go-to telescope, because they're all good for SIN-SCAN alignment. Just point out this particular star, Gamaiza, this pronunciation right, Gamaiza. It's also known as Beta Canis Minoris. As you can see, it's very close to Procyon. The name comes from the Arabic girdle of the bleary-eyed one. I'm not really sure where that came from, but that's what it is. This particular star is about magnitude 3, so pretty bright, easily visible to the unaided eye. It's about 160 light years from Earth, 3.5 times the solar masses, and it's a blue-white main sequence star. Okay, winter deep sky objects. Got 2 here. I've got one that's an unaided eye object, and the other is a binocular or a telescope object. These are deep sky objects that are also part of the Explore the Universe checklist. If you're working through that program. Messier 45, or the Pleiades, is very prominent. It's in Taurus, just above Aldebaran and the Hyades. This particular open star cluster is easily seen by the unaided eye, even in light pollution. So I can step out to my backyard in Halifax and easily pick out the M45 in the night sky. The challenge is if you're going to look for this, see if you can pick out the 7 main stars, because this is the other name for this particular object is the 7 Sisters, and we had a nice talk last month on some of the how this Messier object appears in different cultures. The Pleiades were or 7 Sisters were the 7 daughters of the Titan Atlas and the ocean nymph Pleione. This cluster is dominated by hot blue stars formed in the last 100 million years. The dust clouds, it was thought that the dust clouds were associated with the stars, but it's currently thought that in fact this open cluster is currently passing through a dust cloud, and that's what's resulting in the nice reflection nebula that surrounds the 7 Sisters. In about another 250 million years, it's thought that this star cluster will have dispersed. So catch it while you can. Okay. The binocular target is Messier 47. This is an open star cluster that's about 78 million years old. So it's even younger than the Pleiades, which are about 100 million years old. There are about 500 members in Messier 47. If you look at Messier 47 in binoculars, if you look 1 degree away in this direction, you'll see another Messier object, another open star cluster, Messier 46. So it's pretty easy to tick off both of those. A bit of trivia. At one point, Messier 47 was thought of as a lost Messier object because there was nothing at the coordinates that Charles Messier originally described. And it turns out a Canadian astronomer, T.F. Morris, in 1959, realized that what Messier had done is he'd swapped a plus and a minus sign as coordinates. And if you flip those around, Messier 47 was where it should be. If you missed seeing Algol, the demon star last month, you can, in Perseus, you can have another look for it this month. This variable star is at its maximum, magnitude 2.1 on February 14th. And then if you have a clear night the next day, February 15th, it will have decreased in brightness to magnitude 3.4 at about 9 o'clock. The entire eclipse for Algol and its orbiting companion star is 11.5 hours. And I think I also mentioned last month another variable star to look for, Heinz Crimson star, which is a carbon star, and it's a long period variable. So its change in brightness is over a few hundred years, but its variance is quite dramatic, from magnitude 5.5 to 11.7. And I took this picture of the Heinz Crimson star last month, and in fact, you can see it's a very red star compared to everything else in the field of view. So I think that's all I've got for February. Lots to look at. Hopefully we have some clear nights, and happy to answer any questions.